Good morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's presentation, we are going to discuss about internal treatment of hard water. So far, what we have discussed is what is hardness, how many types of hardness, what are the causes or reasons for hardness, and using which type of units we are going to express hardness that is present in the water sample, and how you are going to identify hardness presence, and then its estimation using EDTA method, and then some problematic part related to hardness estimation using EDTA method. So, and then what happens if hard water it is used. So, now we are going to discuss about internal treatment of hard water. Say for example, if you are using hard water in a boiler for steam generation, it is having hardness. Internally, how we can reduce this hardness. So, that is what we call as internal treatment. So, this is done by adding some kind of chemicals directly to the boiler water and then mixing very well that chemicals after adding. So, they will convert into insoluble precipitates which can be removed by filtration. That's why it is called internal treatment of hard water. So, internally to the boiler water, we are going to add some kind of chemicals which are able to convert into insoluble precipitates so that they can be removed by filtration. So, let us see how it can be done. This internal treatment of hard water is also known as sequestration, in which the ions which are able to cause hardness are prevented from exhibiting their own character. That means by adding some kind of chemicals to the hard water that is present in the boiler, that ions are prevented from exhibiting their own properties or own characters, so that hardness can be prevented, right? That's why it is called sequestration method. And moreover, it is not a preventive method, but it is a corrective method, because its hardness can be reduced up to permissible limit values, but it cannot be totally prevented from the water sample. That's why it is known as a corrective method, but not a preventive method. Let us see how it can be done. It can be done in several ways. So, three were listed here. One is colloidal conditioning. That means some kind of colloidal substances will be added and then mix it well, so that they are able to convert into either insoluble precipitates or in the form of a sludge. So, they can be easily removed by either blow down operation or filtration technique. Another technique is phosphate conditioning. So, in this we are going to add phosphates. In the form of trisodium phosphate, we are going to add phosphate to the boiler water, and then it is mixed very well, so that it will convert into insoluble precipitate form, which can be removed by filtration. And the next one, it is Calgon conditioning. Calgon means calcium is gone. Calcium ions that were present in the water sample. Calcium ions that were present in the water sample will be removed. That's why it is called Calgon. Calcium is gone from the hard water sample by adding Calgon. So, Calgon is nothing but sodium hexametaphosphate. What is the chemical name of Calgon? Sodium hexametaphosphate. If it is added in proper proportions to the hard water sample, it is able to remove calcium salts that were present in the hard water and converts into a soluble precipitate, which can be removed by blow down operation. So, these are the three different methods which we are going to make use under the heading internal treatment of hard water. So, let us see one by one. Colloidal conditioning. As I told you, colloidal substances like kerosene we know, and then tannins. As this water it is not meant for domestic water purpose, we can use kerosene also. And tannins are a class of astringents which belong to the organic complex compounds, astringent group. And in the previous classes, we discussed about this tannins. This can be used to block hairline cracks. During a caustic embrittlement topic, we discussed this tannins concept. So, these are very much useful for blocking hairline cracks in inner side walls of a boiler, that is scales. And then agar-agar. Agar-agar, it is a compound of polysaccharides. If these were added in proper proportions to the hard water sample that is present in the boiler, and it is mixed very well, then immediately what will happen? These compounds, they get absorbed over the scales that were produced in the inner side walls of the boiler. If any scale it is present on the inner side walls of the boiler, then on that scale, when these colloidal substances were added in proper proportions, any one of these three, they get absorbed as a layer on the scale. So after some time, what will happen? They will convert into a kind of a precipitation or a sludge, which is non-sticky in nature, or a kind of loose deposit, which can be easily removed by adopting blow-down operation. So what do you mean by blow-down operation? That we discussed in the previous classes also. So it will contain a tall tower. Forcibly we have to allow the water in batches. So it is able to remove that sludge content, whatever it is present. And at the bottom, we have to collect the water which is free from sludges. So fresh batches of water it is again allowed to pass into the blow-down apparatus for continuous process. So this is called colloidal conditioning. And this colloidal conditioning, it is meant for low pressure boilers. That means boilers which are working under low pressure conditions, we can adopt this colloidal conditioning. So in this, what we are going, it is having a principle, very simple principle. That means we have to add colloidal substances like tannins, agar-agar, kerosene in calculated quantities, and then mix it and convert it into a form of precipitate, which can be further removed by blow-down operation. Let us go with the next, phosphate conditioning. Phosphate conditioning means it is applicable for high pressure boilers, boilers which are working under high pressure conditions. So in this, we are going to add sodium phosphate, trisodium phosphate, or we will call it as sodium phosphate, that is Na3PO4 in calculated amounts to the boiler water. And then if it is mixed very well, then what will happen? So these are the reactions that are going to take place. So if water it is having hardness causing salts like calcium chloride and magnesium sulfate, they will combine with trisodium phosphate, thereby producing corresponding complexes of calcium and magnesium phosphate. So this can be done for boilers which are working under high pressure conditions, and also basing on pH also we can adopt this addition of trisodium phosphate. If it is basic in nature, directly we can add trisodium phosphate, Na3PO4. If the pH it is less than 7, that means it is purely acidic in nature, then we have to add NaH2 sodium dihydrophosphate, PO4. So this can be added, and then it will convert into corresponding soluble complex which can be removed by blow-down operation. So basing on pH, addition will be taking place. That means if pH it is greater than 7, that means basic in nature. If pH it is greater than 7, that means the water sample it is in basic medium, then directly we can add this trisodium phosphate. It is able to convert into concerned soluble soft sludge which can be removed by blow-down operation. If pH it is less than 7, if pH value it is less than 7, that means acidic in nature, the water it is acidic in nature, then we can add sodium dihydrophosphate, NaH2PO4. So this is able to convert into that calcium and magnesium salts into corresponding soluble complexes which can be removed by blow-down operation. So this is about phosphate conditioning, and this is applicable for high pressure boilers. So let us go with next type of conditioning, that is Calgon conditioning. Calgon means calcium it is gone. As I told you, what is Calgon? Calgon means calcium is gone. And moreover, this type of conditioning it is applicable for water which is having hot water sample which is having content of calcium only. Content of calcium only. Okay. So this Calgon means calcium it is gone, and then removal of calcium ions it is carried out simply by adding Calgon. Calgon means sodium hexametaphosphate. Sodium Na6 hexametaphosphate. Metaphosphate means PO3. So this we have to take 6 times. So this complex name it is nothing but sodium hexametaphosphate. So this is what we call as Calgon. So when this is added to proper proportions to the water sample, it reacts with calcium ions that were present in the hot water sample and are able to convert into water soluble compound. So these can be easily removed by blow-down operation. So this is the corresponding reaction. As I told you, Na6PO3 taken 6 times. This is nothing but formula for sodium hexametaphosphate. For convenience, I am going to write like this because valency of calcium it is 2. That means each 1 mole of calcium is able to replace 2 moles of sodium. So here it is 4 moles and that's why it is equal to 2 moles. So in the product we will get a Ca2. That means 2 moles of calcium is able to replace 4 moles of sodium. For convenience of writing this reaction, I have written like this: Na2, Na4, PO3 6 times. On adding to the hard water sample, it is able to combine with calcium ions, thereby converting into a soluble, water soluble compound. So this can be easily removed by pull-down operation. So this is about Calgon conditioning. In today's session, what we have discussed is internal treatment of water. So in that we discussed about 3 different topics. One is colloidal conditioning. Second one is phosphate conditioning. And third one is Calgon conditioning. So these 3 will come under internal treatment of hot water. So in the next session, we are going to discuss about external treatment of hot water. So all these topics so far we discussed will come under internal treatment. In the coming session, we are going to discuss about external treatment of hot water. So that's all for today's class. Thank you so much.